Welcome to SS2 Agricultural Science. Today we begin Term 1 with a vital topic that forms the foundation of all successful farming, advanced soil management, specifically focusing on soil testing. Every farmer in Nigeria, from the smallholder in Benue State growing yam and maize to the large-scale commercial rice farmer in Kebbi State, depends on the soil. But not all soils are the same, and not all soils are suitable for every crop. Soil testing is the scientific process of analyzing soil samples to determine their physical and chemical properties. It tells the farmer what nutrients are present, what nutrients are lacking, the pH level of the soil, and whether the soil structure will support good crop growth. Without soil testing, farmers are essentially guessing, adding too much fertilizer wastes money and pollutes the environment, while adding too little leads to poor harvest. In this lesson, we will explore the methods of soil testing, how to interpret soil test results, and how to use this information to improve farm productivity. By the end of this lesson, you will understand why soil testing is not just a laboratory exercise but a practical tool that transforms farming outcomes across Nigeria. Soil testing matters because soils vary enormously, even within a single farm. A plot in Anambra may be acidic with high aluminium toxicity, while a plot in Kano may be alkaline and deficient in zinc. Soil properties that farmers must know include pH level, which affects nutrient availability, organic matter content, which influences soil fertility and water retention, macronutrient levels, nitrogen N, phosphorus P, and potassium K, which are the primary nutrients for crop growth, micronutrient levels including iron, zinc, manganese, and copper, texture and structure, which affect drainage and aeration. The pH scale runs from 0 to 14. Most crops in Nigeria grow best at pH 6.0 to 7.0. Below pH 5.5, soils become too acidic, and aluminium and manganese reach toxic levels. Above pH 7.5, phosphorus, iron, and manganese become less available. Cassava tolerates pH 5.0 to 7.5, maize prefers pH 5.8 to 7.0, and rice thrives at pH 5.5 to 6.5. Without knowing your soil pH, choosing the right crop or the right lime application rate is impossible. The three common types of soil tests are field tests using simple kits, laboratory tests for detailed analysis, and near-infrared spectroscopy for rapid large-scale analysis used in modern commercial agriculture. The accuracy of a soil test depends entirely on how the sample is collected. Follow these steps for correct soil sampling. First, divide the farm into sampling zones based on visible differences, areas that look different in color, drainage, or vegetation. Each zone should be tested separately. Second, collect subsamples from at least 10 to 15 random spots within each zone using a clean trowel, auger, or sampling tube. Remove surface debris like leaves and grass before sampling. Third, collect soil from a depth of 0 to 20 cm for arable crops, or 0 to 30 cm for tree crops. Fourth, mix all subsamples from one zone together in a clean plastic bucket. Take about 500 grams of the mixed soil as the final sample. Label each sample with the field name, zone, date, crop to be grown, and farmer details. Send samples to a reputable soil laboratory, the Institute of Agricultural Research and Training (IAT) in Ibadan, state agricultural development programs, or universities with agronomy departments. Results typically include pH, organic carbon, available N, P, K, and sometimes secondary and micronutrients. Based on results, a soil scientist prepares fertilizer and amendment recommendations tailored to the specific crop and farm conditions. Once you receive soil test results, interpretation guides corrective action. If pH is below 5.5, apply agricultural lime, calcium carbonate, or dolomite lime to raise pH. The amount depends on soil texture. Sandy soils need less lime than clay soils. Apply at least 3 months before planting to allow the lime to react with the soil. If nitrogen is low, incorporate organic matter such as compost or manure, or apply inorganic nitrogen fertilizers like urea at recommended rates. If phosphorus is low, apply single superphosphate or triple superphosphate at planting time, as phosphorus moves slowly in soil. If potassium is low, apply muriate of potash, MOP, or sulfate of potash. If organic matter is low, practice green manuring, apply farmyard manure, or use crop residue incorporation. The economic benefit of soil testing is enormous. Research shows that farmers who test their soil and follow recommendations increase yields by 20 to 40% while reducing fertilizer cost by 15 to 25%. For WAEC examination purposes, remember, soil testing is essential for rational fertilizer use, prevents soil degradation, and is the scientific basis for soil fertility management. In summary, soil testing turns farming from an art of guesswork into a science of precision. It is the starting point for all good soil management decisions.